Hello, welcome to my final project presentation for the AI product management course. Today I'll be presenting my machine learning project product concept, Smart Home Energy Optimizer, an AI powered system that helps homeowners reduce energy consumption and cost through intelligent automation and personalized recommendations. Let me walk you through my approach to designing this product covering task analysis, user experience design, privacy considerations, and ethical implications. The key points to emphasize on this project are that there's a clear problems and we have defined a solution. We are taking an AI power approach to energy optimization, and we are encompassing all the required elements to focus on a comprehensive coverage. So there are three key items to focus: the problem definition, the task analysis, and the key insights. The problem being that many homeowners struggle with optimizing their energy usage, leading to unnecessarily high utility bills and environmental impact. The core challenge is that energy consumption patterns are complex and difficult to understand without specialized knowledge. For task analysis, I identify the key user tasks as making informed decisions about home energy usage. The current task flow involves monitor usage, analyzing patterns, identifying inefficiencies, making adjustments, tracking results. This is a time consuming process that requires technical expertise for most users, which most users lack. The insight out of this is that users need automated monitoring instead of manual tracking due to the fact that complex data needs to be translated into simple, actionable recommendations. The feedback loop should be immediate to create visual engagement and to maintain visual engagement. These insights lead me to design an AI system that automates the analysis and provides personalized, easy to understand recommendations. To reiterate, monitor, analyzing, identifying, and making adjustments, and tracking results are the highlight insights of the flow of the steps that should be taken. And the need to automate is very important. We don't want to track manually, and creating visuals to maintain engagement with users, very important. For the user design experience, we focused on the user interaction flow. We focused on user inputs, feedback loops, model transparency, and communicating any uncertainties. Focusing on user interaction flow first, users interact with the system through a mobile app and a smart home integration. The AI continuously monitors energy usage through connected devices and provides real time insights. Let me address the four key UX considerations. First, we have user inputs, which consists of passive inputs, including smart meter data, IoT sensor readings, and weather data. Active inputs, including user preferences, schedule information, and comfort settings. The system creates a continuous feedback loop by learning from user response to recommendations. Model transparency, users can access an AI insights section explaining how recommendations are generated. For example, your your AC usage increased 30% this week due to higher temperatures. The AI recommends adjusting schedule to save $15 monthly. And lastly, communicating any uncertainties. Recommendations include confidence levels and ranges. Instead of save $50 monthly, we show 40 to 60% range monthly, which is about an 85% confidence rate of weather depending predictions, clearly indicating variability. Here's the main dashboard showing the real-time energy usage, AI recommendations, and projected savings with confidence intervals. This is a mobile mock-up design, and it shows the features on the app. It shows the confidence bar and the uncertainty indicators depending on variability in the weather. We have privacy considerations, data collection, applicable privacy laws, and our obligations. Privacy concerns, systems collecting sensitive data, home occupancy, device usage, all of which can reveal personal habits and lifestyle information. Data collection, we collect smart meter readings, IoT sensor data, weather information, and user preferences. This data is processed locally where possible, with only aggregated insights sent to our servers. Applicable privacy laws, GDPR for EU users. We provide explicit consent mechanisms, data portability, and deletion rights. CCCPA for California, clear privacy notices and opt-out options for data selling. State utility regulations ensure compliance with energy data protection requirements. For our obligations, implementing data minimization, only collect necessary data, provide transparency privacy notices in plain language, enable user control over data sharing and retention, ensure secure data transmission and storage with encryption, regular privacy audits, and breach notification procedures. So these are all the privacy considerations being taken into account. Now, for ethical considerations, we are focusing on potential bias sources, meeting all the AI goals, ethics, focusing on fairness, accountability, and transparency. For historical bias, training data may reflect past inequalities in energy access. Demographic bias, recommendations optimized for typical suburban homes may not work for apartments or low income housing. Seasonal bias, models trained on specific climate data may not be generalized. Meeting ethical AI goals. Fairness, we ensure representative training data across housing types, income levels, and geographic regions. Regular bias testing across demographic groups with adjustments to algorithm weighings when disparities are detected. Accountability, clear human oversight with energy experts reviewing AI recommendations. Users can easily report issues through the app, and we maintain audit trails for all AI decisions. Transparency, open documentation for our AI methodology, regular algorithm impact assessments, and a public dashboard showing aggregate system performance across different user segments. So these are the three pillars for AI ethical implementations. Now, to summarize, the home energy optimizer addresses a real consumer need through a thoughtful UX design that prioritizes transparency and user control. We proactively address privacy concerns through robust compliance frameworks and ethical considerations through comprehensive bias mitigation strategies. This AI first approach to energy optimization demonstrates how machine learning can create meaningful value while maintaining user trust through ethical design principles. Thank you for your attention. I'm happy to hear your feedback on this project. To summarize, this project resolves a real life problem with AI. It takes a comprehensive approach to ethics and privacy. It values the understanding of creating consumer value, and it creates a framework for developing trust through ethical design. Thank you so much.